So to begin with here, I'm asked to factorise the expression a squared minus b squared. So I'm working with two different square numbers. These are just unknown variables, but it doesn't matter because we're just trying to factorise them here. So we want to basically write this as two brackets which would multiply out to give us a squared minus b squared. Now I've noticed here that we're working with these two different squares and we're working with the difference between them, so one subtract the other. And that's reminded me of the concept of the difference of two squares, often written as dots. And that's basically when we have two square numbers and finding the difference between them. The way that we factorise them is by taking a, so the first one, plus b, and multiplying that by the difference between them, so a minus b. Now if I take these brackets and expand them out, so a plus b, a minus b, a time, if we use the FOIL method, so we can take these two multiplied together and then these two, it's going to leave us with a squared plus ab minus b squared, and then the plus and minus ab cancel out, leaving us with a squared minus b squared as required. Now I'm keeping this idea of the difference of two squares in my head ready for the next part of the question where it might come in useful. So now here I'm asked to, hence or otherwise, simplify fully this expression that we're given here. So x squared plus 4 all squared minus x squared minus 2 all squared. Now this phrase hence or otherwise is making me think back to the previous part of the question and how this idea of these two squares is going to link back to what we just did in the previous part here. So if I have a look at the brackets that we're working with, we have a square subtract another square, and although it looks a bit more complicated, it is again working with the difference of two squares. So if I were to write out it as so, we could write it out as a squared minus b squared. And in this instance, a is going to be equal to what's inside the squared brackets, so x squared plus 4. And b is going to be equal to what's in the second bracket, so x squared minus 2. So now we've set up a and b, and we can use this to simplify the fraction even more so, simplify these brackets. So as with before, we had a squared minus b squared can be factorised as a plus b multiplied by a minus b. Now we can take this and use it to simplify what we have here. So if I take in brackets a plus b, we have x squared plus 4 plus x squared minus 2. And we're going to multiply that by a minus b, so x squared plus 4 minus x squared minus 2. And if we multiply, if we expand out, if we add and subtract and take out the brackets, we're going to be left with 2x squared plus 2 multiplied by, so the x squareds here cancel out, and then we're left with 4 minus minus 2, which is 4 plus 2, so multiplied by 6 basically here. And that's going to leave us, if we multiply this out, with 12x squared plus 12. And then we could even factorise this to leave us with 12 lots of x squared plus 1, just to simplify that even further, but that's not necessary to gain the marks here. And then if I just write this in the box, that is going to gain us the third of the 3 marks for this question. So if I look back at how the marks were awarded here, the first mark would be for using a and b as these values that we've written out, so a is equal to x squared plus 4 and b is x squared minus 2. Then the second mark would be for using the a plus b, a minus b expansion type thing and substituting in the values. And then the final mark is going to be for coming to the correct final answer of 12 lots of x squared plus 1. As this question was a hence or otherwise simplify, we could have gone about it in a different way and expanded the brackets and worked with them this way, and then done some more calculations with the values in the brackets once they've been squared, but that would have taken a lot longer and would have gotten quite complicated and easy to miss out terms. So in types of questions like these, where there's a hence or otherwise, it's usually better to follow the method used in the previous question if that is possible.